Today, we're heading into some really interesting territory where neuroscience kind of meets faith.
Yeah, it's fascinating.
We hear a lot about mindfulness meditation, all its benefits, but what about repetitive chanting, sustained chanting?
It's surprisingly under-researched, isn't it?
Right.
I mean, we have stacks of studies on mindfulness, often showing those increases in alpha, maybe theta brainwaves.
Right.
But these really ancient practices, the ones involving, vocal repetition, intense focus,
Yeah.
the actual neurophysiology has been a bit of a mystery.
So our mission today for this deep dive is to unpack a study that really went for it, a multimodal approach looking at one very specific, very widespread practice, chanting the name of Amitābha Buddha. We want to figure out, is the brain's response here basically just meditation with a different label, or is there something genuinely unique happening neurologically?
And just for context, for anyone maybe not familiar, this Amitābha chanting is a core practice in Mahayana Buddhism. It's all about repeating the Buddha's name, sometimes silently, sometimes aloud, but always with focus, with sincere faith. The aim often involves cultivating compassion, maybe seeking rebirth in the Pure Land. It's meant to be very immersive, very accessible.
Right. So let's dive into how they studied this. Section 1, isolating belief from just plain repetition.
Yeah, the methodology is crucial here.
The researchers obviously knew they couldn't just, have people chant and stick them in a scanner, because any kind of repetition, even just reciting random
Your
words,
grocery list, yeah.
exactly, it's going to cause some physiological change. So they had to isolate the key ingredient, the religious aspect, the focus, maybe the faith itself.
Absolutely. And the rigor they applied is what makes these findings so solid, I think. They used a pretty sophisticated setup.
What did that involve?
Well, they combined high-density EEG that gives you really precise timing when things are happening in the brain with fMRI, which gives you that great spatial picture, telling you where the activity is changing.
Okay, so time and location covered. But the really clever part, and this is essential for you listening, was how they used controls.
Yes.
They had the usual baseline, right? Resting state, eyes closed, no chanting.
Standard stuff.
But the active control, that was the stroke of genius, I thought.
It really was. To control for the rhythm, the repetition itself, even the positive feeling associated with it, they had participants mentally chant a different phrase.
And that phrase was,
Santa Claus old man.
chuckles slightly. I still find that amazing. Using Santa Claus in a serious neuroscience study.
Well, it works. Scientifically, it's smart because Santa Claus old man has a similar sort of linguistic complexity to the Amitābha chant.
Okay, that makes sense.
And crucially, even for people who aren't Buddhist or maybe are atheist, Santa Claus generally carries, positive feelings, positive affective content.
Right. So by comparing the brain activity during the real Amitābha chanting directly against the Santa Claus chanting,
You subtract out the noise, basically, the effects of just repeating words, processing language, feeling generally positive. You isolate what's left.
which should be, theoretically, the unique signature of that focused, faith-based practice.
Exactly. And they did this primarily with a group of intermediate Buddhist meditators for the EEG and ECG data. And then they did a really detailed fMRI case study on a highly experienced Buddhist monastic to get that deep spatial map.
All right, let's get to the results then. Section 2. The brain's unique fingerprint, the PCC and delta waves.
Okay.
So they do the subtraction, religious chanting minus Santa Claus chanting. Where did the biggest difference show up in the brain?
The headline finding, really clear from both the EEG and the fMRI converging, was one specific area, the posterior cingulate cortex, the PCC.
The PCC. Okay, I've heard of that. What exactly was happening there?
So in the fMRI data from that highly trained monastic, the PCC showed the single largest decrease in something called eigenvector centrality.
Okay, eigenvector centrality. Let's break that down. What does a decrease in centrality mean for a brain region like the PCC? Why is that significant?
Think of the PCC as, well, maybe like a major hub or the CEO's office for your brain's default mode network, the DMN.
Right, the DMN. That's the network that's active when our minds wander, when we're thinking about ourselves, planning, sort of daydreaming.
Exactly. It's the internal chatterbox. So a decrease in the PCC's centrality means it's becoming less influential within that network. It's like it's temporarily disconnecting slightly.
Unplugging itself from the main chatter.
Yeah, that's a good way to put it. Less connected, less central to all that self-monitoring and mind-wandering business.
Okay, so the engine driving mind wandering is powering down. That fits with the practice focused on concentration. But what's the mechanism? What's actually causing the PCC to become less central? This is where the EEG comes in.
Precisely. The EEG data showed what was likely driving that centrality decrease. They found that the PCC change was strongly correlated with a significant, localized increase in a very specific type of brainwave during the religious chanting.
Which was?
Delta band power. These really slow brain waves oscillating between about 1 and 4 times per second, 1 to 4 hertz.
Whoa, hold on. Delta waves. Aren't those the waves that dominate when we're in deep, dreamless sleep? Slow wave sleep?
They absolutely are.
So how can someone be actively awake, concentrating, chanting, but have a key brain region showing activity patterns we associate with being, well, deeply asleep? That sounds like a paradox.
It is paradoxical, and it's probably the most striking finding here. You're right, delta is king during deep sleep. But seeing it ramp up so significantly in a specific area like the PCC, while someone is awake and focused during religious chanting, it suggests a really unique functional state.
So it's not sleepiness creeping in.
Doesn't seem like it. It seems more like a deliberate, focused neurological shift, almost like the brain is using these slow, powerful waves internally to quiet things down.
Ah, so instead of relying on external focus, the delta waves themselves are actively inhibiting that internal noise, that self-referential chatter from the DMN, specifically within the PCC.
That's exactly the interpretation. This endogenous or internally generated delta activity in the PCC provides a really neat neurological explanation for why practitioners often report feeling fewer random thoughts, less mind wandering.
Okay.
The slow waves are almost forcing that key region, the PCC, to quiet down, to desynchronize from the rest of that DMN network.
Fascinating. So the brain fingerprint is decreased PCC influence driven by increased delta waves.
Yeah.
Okay, section 3. Body versus brain, looking at cardiac stability.
Right.
Now, whenever you see big brain changes like this, the first question is always, is this just a side effect of something physical? Like, are they just breathing differently, or is their heart rate changing in a way that causes this?
A classic confound to check for. And the study was very careful here. They found that the big brain finding that increased delta power in the PCC couldn't really be explained away by those simple physiological changes.
How did they know?
Because when they compared the religious chanting condition directly against the non-religious Santa Claus chanting, there was basically no significant difference in heart rate variability or HRV, or in their breathing patterns.
Okay, that's really important. It isolates the effect. It suggests the unique brain activity is tied to the mental state, the faith, the focus, not just the physical act of repetitive chanting or breathing control.
Exactly. The neurological difference seems specific to the type of chanting.
Yeah.
However, they did see physiological differences when they compared the religious chanting to the other baseline, the simple resting state, no chanting at all.
Ah, okay. So compared to just sitting quietly, what changed in the body during religious chanting?
Looking at heart rate variability again, the religious chanting led to a noticeable decrease in the overall power or fluctuation, lower total power, lower high-frequency power, lower very low-frequency power compared to just resting.
Lower HRV. Usually we hear higher HRV is better, indicating adaptability, good vagal tone. Why would lower variability be seen as a positive effect here?
It's all about the context.
Yeah.
In many situations, yes, higher HRV is good. But in this specific context of deep, focused practice, the lower power, particularly the reduction across the board, suggests something different. Enhanced stability of cardiac function.
Stability, meaning?
Meaning the heart isn't reacting as much to every little input or fluctuation in the system. It's settling into a very steady, stable rhythm. Think of it less as being restricted and more as being deeply settled, profoundly calm, and unreactive. This decrease, especially in those very low frequencies, is often interpreted as a reduction in the background systemic stress level, maybe even a quieting of the body's cardiac defensive response. It aligns well with subjective reports of feeling tranquil, maybe even spiritually blissful during the practice.
So you get this interesting picture. The body is settling into this profoundly stable, calm state, while the brain is using these deep sleep-like waves, the delta waves, to actively shut down the internal monologue in the PCC.
That's a great summary of the core findings.
All right, section 4. How unique is this? Chanting versus meditation versus prayer.
This really gets to the heart of why this study is important. How does this neurocardiac signature stack up against other practices we know more about?
Well, it seems fundamentally different from a lot of the standard mindfulness meditation research, doesn't it?
Absolutely.
We know practices like mindfulness-based stress reduction, MBSR, or just focused breathing meditation. They often show increases in alpha waves, maybe theta waves. states linked more to relaxed awareness, wakeful presence.
And that's the critical difference. There's even prior research, cited in this paper, showing that mindful breathing meditation actually decreased delta power compared to resting.
Wow, the exact opposite.
Exactly the opposite of what they found for this religious chanting. So the way these different practices achieve a state of mental quietness, or how they impact the default mode network, seems to rely on quite different neural mechanisms. Chanting is using delta. Mindfulness might be using alpha or theta, or perhaps reducing delta.
And what about other forms of prayer, say more petitionary or conversational prayer common in Western traditions?
That might be different again. Some studies looking at, say, Christian prayer have found associations with increased alpha and sometimes gamma activity gamma, often being linked to moments of insight or intense focus and binding of information, not necessarily this profound delta increase.
So this specific combination, the PCC quieting via delta waves plus the cardiac stabilization, seems fairly unique to this type of focused, repetitive, faith-based chanting.
It certainly appears that way based on this evidence. And the implications of that delta increase are quite profound.
Why delta specifically?
Well, delta activity, as we mentioned, is linked to deep sleep, but more broadly, it's often thought to reflect very fundamental, perhaps evolutionarily ancient, states where the body and brain engage restorative processes, replenish resources. It's deeply tied to rest and recovery.
Okay, so what's the potential application then? If we know this specific practice boosts delta in the PCC, how could that be useful?
The researchers themselves suggested some interesting possibilities. They proposed that practices like this Amitābha chanting, ones that reliably trigger this delta response, could be particularly beneficial for conditions related to poor rest or recovery.
Such as?
They specifically mentioned potentially treating sleep disorders, which makes intuitive sense given the delta wave connection.
Right, harnessing a waking delta state to help regulate sleep delta.
Perhaps. And they also hypothesized potential benefits for managing addiction craving.
Addiction, how does that connect?
The idea there relates back to the PCC and the DMN. That network is heavily involved in self-referential thought, rumination, and potentially craving states. So a practice that actively dampens down the PCC's influence, using these powerful inhibitory delta waves,
might help interrupt or reduce those cycles of craving.
That's the hypothesis. It's speculative, of course, but it opens up interesting therapeutic avenues based on this specific neural mechanism.
Okay, let's wrap this up, the outro.
Mm-hmm.
So the key takeaway nugget for you listening. This specific kind of religious chanting, like the Amitābha practice, seems to create a really distinct neural fingerprint. It's characterized by the posterior cingulate cortex, the PCC, becoming less influential. Less central in the brain's self-talk network. And this quieting appears to be driven by a surge in powerful, slow delta waves, the kind usually seen in deep sleep.
And alongside this unique brain state, the practice also promotes remarkable cardiac stability, a deep functional rest in the body.
And importantly, this whole pattern looks quite different from what we typically see with many popular forms of mindfulness meditation, which often involve different brainwave patterns like alpha and theta, and even show the opposite effect on delta.
Which leads us to our final provocative thought for you to consider. The researchers explicitly suggested something quite profound in their discussion.
What was that?
They hypothesized that if they ran this exact same experiment, comparing the Amitābha chant to the Santa Claus chant, but did it with a group of participants who are not believers, who didn't hold that specific faith.
Okay.
They predicted that the unique neurological difference, that delta surge in the PCC during the religious chant, would likely disappear. The two chanting conditions would look much more similar in the brain for non-believers.
Wow. So the implication is the physical repetition, the sounds, the rhythm, that's not enough on its own to trigger this specific, powerful delta state.
That's exactly the implication. It raises this really fascinating question about the role of sincere faith. Is it the belief itself, the emotional connection, the focused intention rooted in that faith? Is that the crucial ingredient needed to unlock this particular, deeply restorative neurological pathway?
It suggests it's not just a cognitive technique, but that the subjective state of belief might be actively shaping brain function down to the level of fundamental oscillations like delta waves.
Precisely. It implies that faith isn't just an abstract concept, but something with potentially measurable, potent neurophysiological consequences. Definitely something to mull over as you continue your own deep dive into the mind.